Okay, so what we're thinking about today is horizontal shifts. And this horizontal side to side shift that you're seeing is happening to make Rodrigo Alvarado's graph from last year. He did a wonderful job with this Doodle Bob character. Now, what's weird about this, I don't know if it felt weird to you, is to me, I guess this felt backwards. What you saw on the launch is when k is positive, the graph goes to the left. But when k is negative, the graph goes to the right. And to me, I guess that's always felt backward. I've thought like negative should be left and positive should be right. And so I want us to sort out why would it be? And I actually want to start with the example of a quadratic. We've seen this before. And remember that f of x equals x squared has a 0 right here at 0. And when we graph g of x, x plus 1 squared, notice that, remember, this function has a 0 at -1, right? Because we need -1 plus 1 to make 0. So that's what we see here, is when we have x plus 1 in the parentheses, our vertex moves to -1, our 0 moves to -1. Let's do a couple more examples of this. If we had x plus 3, what would the 0 of this be? Well, we need -3 plus 3 to make 0, so we see that at -3. In other words, this should remind you of quadratics where we needed to take the opposite number, excuse me, the opposite sign of what was in parentheses in order to make a 0, right? If we wanted to have a 0 at -3, we needed to have the opposite sign in parentheses plus 3. If we want to have a 0 at +4, we need x minus 4 in our parentheses. The same thing's going on here with the inputs into our functions. Oops. So even if we take an example that we haven't seen before, the square root of x, thinking about what would make that x value move to -1 would mean that we need to add 1 to kind of counterbalance that negative. So when we see x plus 1, that moves to the left 1. If we say x plus 5, that moves to the left 5, right? Because every old x value will move 5 values to the left, and so we need to add 5 to balance that out. If we want to move this to the right, we would say f of x, h of x minus 5. So notice our changes here go into the inputs inside the parentheses or inside the square root symbol, but always inside that grouping symbol. And they have maybe the opposite sign or the opposite direction that you might expect. That's why that works.